looking at factorising quadratic expressions. Firstly, let's look at the idea of taking out a common factor. So for a, we've got 4a squared plus 6ab. So obviously 2 is common to the numbers, and we've also got a being common to the variables here. So we'll take out 2a. So 4a squared divided by 2a will leave me with 2a, and 6ab divided by 2a will leave me with 3b. For question B, I've got 6xy plus 3x squared y plus 24xy. So 3 is common for the numbers. X's appear in the variables, and so does y. So I'll take out 3xy. And you can see 6xy will just become 2. 3x squared y, 3 will be gone. The x squared will become just x. And the y has been taken out and taken care of with this 3xy here. 24xy cubed will become 8y squared. So nothing startling there, pretty simple. For C, it's a little bit different. All right, so it's the same approach, taking out a common factor. We've got 2a being multiplied by the bracket a plus b, and we've got 5 lots of the a plus b. So if I think of this as being the first term and this the second, what's common to both of those terms is the bracket a plus b. So if I take the a plus b out and then open up a bracket, for this first term, if I have 2a being multiplied by a plus b and then I divide by a plus b, I'm going to be left with 2a. And for the second term, if I've got 5 lots of a plus b and I divide by a plus b, I'm going to be left with 5. So that's how we come from this situation to 2 brackets. We're now going to factorise quadratic trinomials, and the method I want you to understand, and it's a really good method, is known as the grid method. So I understand a lot of you would have been using the PSF, and that's fine. For the simple ones, you can keep on using the PSF method, but it's important that you understand how to use the grid method, because when we have more complicated quadratics, they're more easily factorised using this grid method. So I'll show you the technique. So for the first one here, for A, I've got x squared plus 7x plus 12. I start off by setting up a grid. So I've just got that grid here. So just ignore the numbers and the variables at that stage. There's my grid. I then list the factors of the first term. So in this case, it's x squared. So what are the 2 factors of that? X and x. So I have an x and an x. I then write down on the right-hand side of the grid all of the different combinations of the factors of positive 12. So I've got 6 and 2, 12 and 1, 3 and 4. Next, what I do is cross-multiplying each of these sets to see which one produces a 7x. The one that does produce 7x is the right combination. So, cross-multiplying x times 2 is 2x, x times 6 is 6x, that equals 8x. 8x is not equal to 7x, so that's no good. So I'll put a little cross there, put a cross here. Next one along. X times 1 is x. X times 12 is 12x. That equals 13x. And that's not equal to 7x, so I know that that's no good. Then finally, x times 4 is 4x. X times 3 is 3x, and I get 7x. That is the middle term, so I know it's the right combination. So the way I'll write this down is it's x plus 3 in the first bracket, and it's x plus 4 in the second bracket. And you always read it that way. Okay, so the factorisation of B is given there, and C, and let's look at the grid method again for D. So I've got 3x squared minus 10x plus 8. I rule up this grid. I then look at the first term, 3x squared. What are the 2 factors of that? 3x and x. I write those down. I look at the last term, and it's positive 8. So I'm going to write down all the factors of positive 8. But notice that when I do the cross multiplication, add them together, I need to get a result of negative 10x. Now the only way we can achieve negative 10x is if we're adding negative numbers. So these factors of positive 8 must be both negative. So I'm only going to consider the negative factors of positive 8. So I can have negative 8 and negative 1. And because the 3x and the x are different, I also need to consider having negative 1 and negative 8. And I've got negative 4 and negative 2, and of course negative 2 and negative 4. And now I go through systematically and do cross multiplication, add them together, and see which one produces negative 10x. 3x times negative 1 is negative 3x. X times negative 8 is negative 8x. Add them together, I get negative 11x. That's not equal to negative 10x, so I know that that's incorrect. So I dismiss that. Next one along. 3x times negative 8 is negative 24x. X times negative 1 is negative x. Add them together, negative 25x. Still not negative 10x. Next, 3x times negative 2 is negative 6x. X times negative 4 is negative 4x. Add them together, negative 10x. That is the middle term. So I know that this is correct, so I tick that combination. And now I simply write down the bracket. So it's 3x take away 4, and it's x take away 2. And that's how we should factorise quadratic trinomials. Of course, as you become better with this technique, you can start guessing the correct combination really quickly. And also you become really good at this technique that you can do it all in your head. And so it's quite easy for us to come up with that quadratic there and then factorise straight away without any kind of working out at all. It really lends itself well to being able to go from there to there quickly. All right, for E, what's common here is 2 in each of those terms. So I take out 2, and then I've got x squared plus 7x plus 6. So I want the factors of 6 so that you add them together give you 7. So it's x plus 6, x plus 1. Here I've got a bracket squared plus 5 lots of that same bracket plus 6. So I'm just going to make a substitution here. I'm going to let the bracket equal u. So u equals x plus 5. So I now have u squared plus 5u plus 6. So I want the factors of 6 so that when you add them together give me 5. So it's going to be u plus 3 multiplied by u plus 2. I now go back and say that u is equal to x plus 5. Collect like terms, and so it becomes x plus 8 multiplied by x plus 7. Now the difference of two squares, something squared minus something else squared, we can rewrite it like this. So a squared minus b squared is a minus b multiplied by the bracket a plus b. So I recognise the x as being a, and this 49 I can rewrite as being 7 squared. So I have it in the format a squared minus b squared. So it becomes x minus 7, x plus 7. For b, I've got 16x squared minus 121. So I rewrite 16x squared, so it's 4x in bracket squared minus 11 squared. So it's 4x take 11, 4x plus 11. For c, 2 is common, so I take out the 2. So it's 2 lots of x squared minus 9. I can rewrite that as being 2 lots of x squared minus 3 squared. So it becomes 2 lots of x take 3, x plus 3. For d, I can rewrite this as being x minus 9 squared take away 4 squared. So now it's in the format a squared minus b squared. So it's going to be x take 9 minus 4 in the first bracket, and it's going to be x take 9 plus 4 in the second bracket. Tidying things up there gives me that. And for e, I've got 16 minus 25 lots of x minus 2 all squared. So what I'm going to do is get into the format a squared minus b squared. So the 16 becomes 4 squared, and the 25 lots of x minus 2 squared becomes 5 multiplied by the bracket x minus 2 all squared. And now we just go through and apply our a minus b multiplied by a plus b. So 4 minus 5 lots of x minus 2, and then 4 plus 5 lots of x minus 2. Expand the brackets, collect like terms. Use our CAS calculator, as you can see here in problem 4. Whilst this A and B are quite easily, we can factorise quite easily. You can see what I've done here in red. And we use our CAS, menu, algebra, and factor. And in the first one, it was 4x squared minus 4x plus 1, and gives us 2x minus 1 squared. And then menu, algebra, factor, and we've got x to the power of 2 minus 7x. Now I'm hoping obviously you can do that in your head, but there it is.